Hi and welcome to Quark's Python uh, learning courses. This is my first time doing doing a refresher on Python, so I'm making these videos for myself. But if it helps you guys, I really hope it does. So on this one, we're gonna learn how to identify if a number is odd or even. So first thing is we're gonna do is we're gonna use the modulus, that percent sign right here. And so what modulus does is it takes, let's say that you have a number, actually, let me draw it out because it's a lot easier that way. Okay, so let's say we have a number 11 and we want to mod it. So like mod 5, right? And so how many times can 5 go into 11? It's 5 plus 5 plus 1, which means uh, twice, and then we have a remainder of 1. So what mod will do for us is it will divide the total number here by 5 as many times, and then whatever remains will be our value. So 11 mod 5 will equal 1. Now, does that mean it's even or odd? No, because the lowest division we can go for to verify that it's odd, or at least from my understanding, so again, very limited refresher, would be using a 2. So 11 mod 2 so if anything is, let's say, divisible by 2, like so long as there's one remainder or we get 1 back, we know that it's odd. And if not, then we know it's even. Because if you do it by 5, like, actually by 5, let's see, 117, so 115. And then we would have a remainder of 2. So yeah, we wouldn't really be able to tell that it's, what's it called, odd or even just from like getting the first value. So that's why we go by mod 2 to identify whether it's even or odd. So 11 divided by 2, and we get what? 10 times 10 divided by 2 is 5, and then we get a remainder of 1. So now we know that, hey, this number is odd. Yay! Okay. Let me erase that and give you an example of even. I know it's really easy for you guys, but again, making these videos to remind myself. So let's say I want to know if a number is even, so 170772, right? Modded by 2. So we know that everything here is divisible by 2 because even the n number here is 2. So we're not going to have any remainders. We're going to get 0. And with 0, we know that it's even. All right, so now let's move on to actually applying that over here. So, all right, we're gonna go with print. And then let's see, our number would be 17772 that we just used, mod by 2, and then we print it, control save, Python over here in our terminal, then y, and run it, and we get a 0. So now we know, hey, this number is actually 0. Let's extend things a little further. So let's make a little function, def is odd, even, and then number for an input here. Let's see. Odd, even equals num mod 2. And then if odd even is equal to 1, because if we're like modulus is just going to give us a remainder, and like the only actual values that a mod 2 will give us is 1 or 0. So that's why we're doing it like that. Well, that's why we're only putting 1, and then we're going to put an else, and like, because it doesn't matter what else it gives us, because it will only give us that. So then return print odd. All right. Then else return print even. All right, cool. Now we have our definition, our function defined. Let's get some input here. So is odd even, and put whatever number we want. Like, let's put a 2. Well, actually, yeah, let's put a 1 here and see if it'll work. All right, let's run this again. Make sure you save it. Cool. Now we know it's odd. Let's put 8. Let's run it again. Make sure we save that. And even. Okay, so now we have a function that will use the modulus to identify if a number is odd or even. So great for us. So let's move on to floor division. So what floor division will do is it will, let's say we have 11 divided by 2, right? It will divide it like normally, so we'll get like 5.5, but it'll floor that division, so instead of getting 5.5, we'll get 5. Again, we can still use that to identify whether a number is odd or even, and I'll show you. Let's go back to GIMP and clear this out. Alright. Okay, so floor division, let's go 11 by 2. And again, we know we're using 2 because it's you'll probably correct me later, but it's how I'm learning it. So let's go with that for now. All right, so if we divide this, this will give us 5.5, but we're in floor division, so we go to the lowest. So now it's a 5. So how do we actually identify that it's odd or even? So because we're dividing by we're dividing by 2, like the remainder is either 1 or 0, right? So, and how do we get that remainder? We can't do it here like with mod, so it's gonna be like this. So 11's our total. Then we're gonna subtract it by 11 floor division 2, which will give us 5 times 2, which is 10. So 11 minus 10 is equal to 1. And it's as simple as that. So then let's say 7, 2, right? Think of this as x. So then if we do some, I guess, algebra here, so then we would take x minus x, floor division of 2, multiply this by 2, it would give us the remainder. So this would be our y here. And then if this one is 1 or 0, we'd be able to identify whether it's odd or even. So I hope that helps, because I know it helped me. Let's go clear that out. And let's actually apply it. So let's see, print C77743 for division by 2, but again, we're taking this big number, Control C, subtracted, multiplied by 2. Okay. Actually, let's do this real quick so we can see it. Python 3, and then did not work. Okay, let's just get out of that and run that. So we know that it's from this, so that's even. And then we have the floor division that is giving us a 1. Actually, let's just comment that out so we don't have to focus on that. Okay, let's Control V and paste, and then let's do a 2. Let's identify if we're going to get a 0 or not, but it should get us 0. Let's do this again and see, 1 and 0. So regardless of what this might be, we'll get either a remainder of 1 or 0, so we can identify that the numbers are odd or even. Whoa, 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 what's going on here? Why is that 6 or 7? That should, no, I forgot to update the numbers here. Okay. All right. And there we have it. Okay, cool. Let's create a small function. That way we can use this floor division a little easier. All right, so let's copy this. Let's just name it floor. It's on even numbers. So then for here, it would be the num minus num floor division of 2 times 2. Okay, and that would be pretty much it. So then let's print is odd even floor. All right, and let's put an input of whatever we like. So make up a random number. All right, cool. Big number, right? Then save and go up and terminal, and let's go. Okay. Okay, that is what's going on here. None. It should not be giving us none. We might have done something here wrong. Okay, so it takes in the number, odd, even. Where's it getting none from? Maybe it's too much of a big number. So notice we know it's odd or even, but where are we getting that none from? I don't know, but we get the function working, so we're good with that. All right. All right. So now, let's say that you're in an interview and you're told, hey, I need you to show me how you can identify whether a number is odd or even without using the modulus or the floor division. Like, how do you go about it? Um, and one of the big things you have to do is like communicate how you do it. Not so much if it's right, but okay, it's important, but it's more so important that when you're interviewing for like development things, that you can communicate how you got there. So I think it's like a whiteboard interview or something like that, and I am terrible at those, even if I know what I'm doing. So yeah, let's give it a shot. We need this while loop. Let's copy this, Control C, and we're gonna put it right here and let while. Okay, so let's go back to our whiteboard here. Let's increase the canvas size because maybe that'll help with things. Okay, so with a while loop, it's like while x is not less than, sorry, while x is less than 0, do this. So we're going to use this to help get a number and bring it down enough that we will just get the remainder. Essentially, we're just doing division, but with a while loop. So let's show you really quick examples. Okay, so let's say total would be like 12, right? Okay. So for total, we're going to do the while total is greater than 0. And so, let's also add a count here. Count, and this is equal to 0. All right. While this is greater than 0, while total is greater than 0, we're going to take 2 out of it. So total equals, sorry, minus equals, or minus equals 2. So this will just subtract. It's the same thing as saying total minus 2. Total equals total minus 2. But we're just doing minus equals right here. All right, and then we're going to do a count plus plus, which is just the same thing as count plus 1. This is just to simplify things for us. Okay, so then this will keep counting until total is until this becomes false. So when total is less than or equal to 0, then we'll get out this loop. So if we have 12 divided by 2, we're going to have 6 on our count, right? So now we know that, hey, 2 divides into 12 6 times, and so then we can be like, okay, our total minus 2 times 6, which is equal to 0, and so now we know that this number is even. All right, so we're going to do the same thing again, but let's say with an odd number. So CT 17, and then WT less than, well, T is greater than 0. Okay, cool. And then C plus plus and T minus equals 2. All right, and then we loop around. We know that 2 goes 8 times into 17. So then we get our count of 8, and from that we'll do our remainder. Yeah, we'll name a remainder, and that will equal 17 minus 8 times 2, which will give us a value of 1. And so we know that r, or the initial value here, is odd. And that's pretty much it. And so let's code it too. All right. All right, and let's do this real quick. Let's see. Count equals 0. Total equals num. Or actually, we don't need that here. All right. While num is greater than 0, count plus plus. Actually, count equals count plus 1. Let's just do it the old way, and then num equals num minus 2. All right. And then when we're here, this is going to be our odd even, actually no, our remainder, which is going to equal to our num minus count times 2. And then remainder, so if our remainder is 1, it's odd, and otherwise. All right, and then while, cool, we got our entire function ready. So let's print, print is on even while, and let's add a value of, let's say, just 11, just to test it out. Comment that out, clear, save. Cool. We know, wait, no, that's not right. Okay, let's check our code. So num count is 0, while num is greater than, we definitely did something wrong here. Let's think about it. Okay, so 11 count, okay. So when this is 10, when 10 is subtracted from 11, we'll have a remainder of 1. Let's print this out. Let's do some quick rebugging. And yeah, you should also take this into account. Like, they're going to give you different types of inputs, and you have to explain, like, hey, how would you catch this? And address, yeah. So negative 13. How are we getting negative 13? Our remainder is negative 13. How? Okay, let's print count. So our remainder is, our count is 6. Let's print num here. Let's clear. Okay, so okay, I see it's going way above this. Okay. Oh, and it's taking this number. Okay. All right. Okay, that makes sense. Okay, so we do need to add another here. Total equals num, and then total total. All right, there we are. So what's happening is that because we use num here, um, it's the value of what this of num or right here is the number from this while count. So it'll give us the wrong remainder every time. So what we need to do is add total, equate that to num. So now it's its own dependent thing. Then we go through the process and we get back our initial number here, num, and then multiply it by the count calculated here, then multiply it by 2, and that will give us the correct remainder. But let's do some more troubleshooting here. So print total, and then print total. So we know what the total value is at the beginning and then after our while loop. All right. So we put in 11, our initial value total is 11. Then after the while loop, we're going to get a total value of 1, which should not be happening. Then our actual value is num here, and then 6 for the count, that's right, and then the remainder is -1. Okay, that is definitely wrong. We should not be getting that at all. Okay, so what's going on? Okay, if total is greater than, when total is less than 0, maybe it's the other way around, while total is greater than 0, greater or equal to 0, so that way it doesn't pass things up, because our total here should be like 1, not -1. Alright, but I mean, that could still work. Yeah, actually that still works. Let's see. No, that does not work because we didn't even. We can do like an ABS kind of thing. No, counts 6 times 2, yeah. Wait. No, this should only go in 5 times. Yeah, okay. That is actually the issue. All right, and then clear. Yeah, still an issue. So this needs to we need to focus on this right here. All right. Let's see, how can we make it so that it will stop once we can't divide by 2? Okay, so let's see. Well, total is greater than 0. Keep doing this. Let's put this over here. So we would do this. Let's add a new if statement. So if total okay, let me get off and think about this and then I'll come back. All right, So we troubleshooted and we've broken things down even further and simplified things. So now we got rid of the total number, the count thing. All right, so this is how it goes. So we add in a number, right? While that number is less than 0 or equal to 0, we're just going to add this here because we want to be able to print out our numbers here. See, I'll show you. So without the equals, so we do our iterations where it's the num minus 2, and then we keep going until we find that we either have 1 or we have 0. If we have 1, it's odd. If we have 0, where it's even, because let's say 10 divided by 2, that's 5 times, right? So you would have nothing, so that's why we put 0 here. Last time, or one of my troubleshootings off the camera, I tried this, but with just else, and so it didn't register in my head until like 5-10 minutes that like whatever number is here doesn't matter because I have that else. It'll just return even every single time. I won't even do the -2 because again, whatever number. So I put 0 here. All right. So let's test this out. Let's see that it's even. Python. Okay, we go through an iteration. We get down to like 2, and something's not working right. So then we put 0. We put equals right here. We try it again. And what that tells us is that we need this right here. So either the number is greater than 0 or it equals to 0. But when it is equal to 0 right here, it goes through all our iterations correctly and then it gives us the right number. Let's go with an even number here. All right, so 21 all the way down to 1. And let's take this out right here, just to be real quick. So 21, it will work every time for odd, but not for even. So that's why we need that little equal sign, just to, so it goes through the loop once more for that last iteration to make it even. And if I'm not making sense, I apologize. Again, just communicate. You gotta communicate, even if you don't make sense, because if you can't identify what you don't know, you can't ask the right questions, and that's really important. All right, let's see. Let's add a huge number. 1. All right, we should be able to identify that it is. Okay. Let's Control C. Control C. All right, that. Let's take this out. That's too much. Okay, maybe it's taking too long. That's true. This is a big number. Okay, let's do something a little less big. The runtime is terrible. Okay, odd. Great, we got it. Let's see, 7.7. That shouldn't be too bad runtime wise. Okay, nice. We know it's odd. All right, now let's see. 8. We should get even. Cool. All right, so now we figured out how to use a while loop to get to identify whether a number is odd or even. We've gone through the code in basic steps to identify how to reduce the complexity or how to reduce the lines of code as well. I hope this really helps. I know it'll help me when I come back to this because I'll probably forget. But no, for like interviews. All right, so we got modulus, we got floor division, and then we got like without either modulus or floor division using a while loop. So I hope this helps, and good luck out there. Till next time.